Good morning everyone. Today again we will continue our numericals. Okay. So here first numerical it is given. Calculate the molality of Ki if density of 20% mass by mass aqueous Ki is 1.202 gram per milliliter. Okay. What you have to solve here? Molality. Okay. For calculation of molality first you should know what is the meaning of 20% mass by mass. Okay. So upside mass and down also mass given. It means whenever this quantity is given in percent, it means this is the value for solute in 100. Okay, in 100 gram. Why we have taken the 100 gram? Because down mass given. Okay, and percent is always taking in 100 quantity only. Okay, in 100. Okay, so how much quantity of solute present here? 20 gram in 100 gram of solution. Okay, mass by mass given here. So you can solve the molality very easily, because what is the formula of molality? It is equal to moles by mass of solvent, okay, in kilogram. But here in gram it is given, and this is the value of solution. 100 gram, it is the value of solution. So you have to calculate the mass of solvent. How you can solve? 100 minus 20. So this is given here. Mass of water is equal to 100 minus 20. Solution minus solute, it will give the mass of water. Okay, so that value you can keep down, mass of solvent. Now upside what you need? Moles of solute. So moles of solute, how you can solve? How much quantity of solute given here? 20 gram. So what is the formula of moles? Given mass by molar mass. So given mass it is 20 and molar mass of Ki it is 166. So you can solve the value 0.120. This is the moles of Ki. Okay. So you can see molality is equal to moles by mass of solvent. So moles we have solved, it is 0.120. Okay, this is the moles of what? Solute. And mass of solvent, it is 80 gram. Okay, so 0.120 divided by 80 into 1000 you have to do. Why? Because it is given in gram. So you can solve by this way molality of the solution. So this we have solved here, molality 0.120 by 0.08. Okay, so what value you have got? 1.50 molality. Okay, but you can see here in this numerical, density also given here. So what's the use of this density? Because in next part you will see here, this is the part of that question only. So you can see density that was given 1.202. Now we have to use this, because now we need to solve molarity. So what is the formula of molarity? It is equal to moles of solute divided by volume of solution. Okay, volume of solution. So in first numerical we have calculated the mass of solvent that was needed in molality, but here what we need? Volume. Okay, in numerical it was given in terms of mass. So now we can use the density. Okay, so mass, by using mass and density we can solve the volume. So what is the relation? D is equal to mass by volume. Density is equal to mass by volume. So you need volume. So how you can solve? Mass by density is equal to volume. Okay, so you can see density is equal to mass by volume. Okay, then volume is equal to mass by density. So of solution you can get the volume of solution. Okay, because it is given mass of solution. So mass of solution, it is 100. We have seen in percentage it is given now. So 100 by density, it is the volume. Moles we have solved already. Okay, of solute, it is of water. Of solute we have solved. So molarity you can solve. So now you can see moles of solute and volume of solution is equal to molarity. You will get the answer 1.44 molarity. Okay. Now what you have to solve, third part, mole fraction. So what is the formula of mole fraction? It is represented by X. Okay. So mole fraction of solute, if you want to solve, then how you can solve? Moles of solute means of Ki mole fraction is equal to moles of solute divided by moles of solute plus moles of solvent. Okay, so that I will write here like this. Any symbol you can use. Okay, so mole fraction you can solve in this way. Means of mole fraction, whatever you want to solve, of that moles you have to keep upside and total moles you have to keep down. Okay, so you can see moles of solute we have already solved in first part. Okay, so moles of solute down also you will keep. Now what you need? Moles of solvent. Okay, so mass of solvent, it was already given. We have calculated by this way, 100 minus 20. It was the mass of solvent. Okay, so moles of solvent, how you can solve? 80 by 18. Okay, 80 by 18, it will give the 4.44 value. Why you have used this 18 value? Because it is the mass of molar mass of solvent that we have taken water. So you can solve the mole fraction also. Is that clear to all? Now next numerical, it is H2S gas, toxic gas with a rotten egg smell is used for the qualitative analysis. If the solubility of H2S in water is at STP 0.195 molality, calculate the Henry log constant. You can see here this value solubility it has given in terms of molality. Molality, it is lity. Okay, 0.195. Okay, but you should know one more thing. At STP, the pressure is always equal to 0.98. At STP, how much pressure? Pressure is equal to 0.987 bar. Okay, this quantity you have to learn. Many times they are giving in numerical, but some of the time they are not giving, so you have to learn this. Okay, so pressure it is given here, molality it is given. Now what you have to solve? Henry log constant. Okay, so we have done already the chemical formula of this. According to Henry, partial pressure of solute or that component is equal to Henry constant multiply mole fraction of that solute. Okay, so mole fraction of solute, how you can solve? X is equal to moles of that solute, whatever you need, okay, divided by total moles. Okay, so for calculation of moles, you need given mass by molar mass. So with the help of molality, you can use this term and you can solve the mole fraction. Okay, so molality, whenever this value it is given like this, the molality how much given? 0.195 molality. What does it means? It means 0.195 moles of H2S. It is present in 1000 gram of solvent. Okay, it is present in how much? 1000 gram of solvent. Okay, so given mass of solvent we have got 1000 divided by 18, its smaller mass. Now after calculation you will get 55.55. So moles of solute, it is already according to this value na, molality 0.195. So moles of solute, it is given 0.195 divided by again moles plus mass of solvent. Okay, total moles it is given. Now you can solve the mole fraction. Okay, partial pressure according to STP we know how much value it is, 0.987. Okay, so you can use this terms and you can solve the KH value. Finally you will get the answer 282.80 bar. Okay. So next numerical, it is Henry law constant for CO2 in water, it is given 1.67 into 10 to the power 8 Pascal at 298 Kelvin. Calculate the quantity of CO2 in 500 ml of soda water. Quantity of CO2 means it is asked given mass of CO2. Okay, this value you have to find out. When it is packed under 2.5 atmosphere, it means it is given pressure. Okay, partial pressure it has given to you. So now how you can solve? First you have to use the Henry law formula. Okay, it is partial pressure is equal to kH into mole fraction of that solute. Okay, so mole fraction of that solute, you have to solve this. Okay, so how you can solve? Partial pressure of CO2 divided by kH. Okay, it is equal to mole fraction of that solute. Okay, so partial pressure it is given already, that is 2.5 atmosphere, but you have to convert this into Pascal. So by multiplying with 101325, so partial pressure you have got. Okay, this value you can keep here. Now what is the value of kH? It is also given to you 1.67 into 10 to the power 8 Pascal. Okay, this you can keep here. So mole fraction of carbon dioxide, you can solve by this way, then answer will be this one. Okay, but actually in numerical what they have asked, given mass of the solute means of carbon dioxide. So you can easily solve by using a mole fraction. Mole fraction is equal to moles of CO2 divided by total moles of component that you have kept down. Okay, so moles of water, how you can solve? Actually in numerical it was given 500 ml of soda water. It means in that CO2 gas present and water present. Okay, but carbon dioxide it is a gas, so whatever the quantity of that soda water, it is equal to the mass of pure water only, because carbon dioxide is a gas, you can negligible the mass of CO2 here. So whatever volume you have taken of soda water, it is equal to the volume of pure water. Okay, but density of water it is 1. Okay, 1 gram per centimeter cube. Density is equal to mass by volume. Volume it is given to you of pure water, that is 500 ml. Why you have taken 500 ml equal to solution? Because carbon dioxide gas solubility you can negligible here, means of that volume you can negligible. So volume of solution becomes equal to volume of pure water. But by using this you can solve the mass. Density of pure water it is equal to 1. So volume is becomes equal to mass of solvent only. Okay, so by using mole fraction, okay, so moles of water you can solve 500, that is given to you, divided by 18 moles of water you can get. Okay, so you can keep all these value. Mole fraction we have solved, moles of CO2 you need, moles of water we have solved here. By using this you can calculate the moles of CO2. Okay, moles of CO2 that we have got 42.20 into 10 to the power minus 3. Now given quantity, given mass you have asked na, so moles is equal to given mass by molar mass. Moles you have solved here. Molar mass of solute you know, that is 44. Carbon dioxide molar mass it is 44. Then given mass you can solve. So this is the final answer, 1.857 gram. So again I will tell you this numerical, little it is difficult. Henry law constant it is given to you. Calculate the quantity of CO2, means given mass of CO2 you have to solve. 500 ml of soda water it is given. This you have to keep equal to volume of water, pure water. Why? Solution becomes equal to water, because quantity of CO2 that is dissolved you have to negligible it. Okay, but by using volume of water you can solve the mass of water, because density is equal to 1. Okay, How much pressure it is given? 2.5 atmosphere. Okay, 2.5 atmosphere, you have to convert this into Pascal. Okay, if needed, otherwise you have to go according to numerical. Okay, so why you have to convert this into Pascal? Because in Henry constant it is given in Pascal. Okay, so by using all these formulas, Henry law constant formula or Henry law formula, partial pressure is equal to kh into mole fraction of that solute, you can solve the numerical. Okay, so in next lecture we will solve this numerical. Okay, that is based on vapor pressure. Okay, so you have to do up to this. Thank you and have a nice day.